how we can predict the structure of a molecule based on their hybridization. And for that we have to use the VSEPR theory, valence bond electron pair repulsion theory. In VSEPR theory, first we need to find out the hybridization of the central atom of a molecule, and for that we have this formula: H is equal to V plus X by 2. So in this case, H represents the hybridization. What will be the hybridization of the central atom? And V is the number of valence electrons present in the central atom, or number of electrons present in the valence shell of the central atom, and X is number of monovalent atoms. Now if you have a charged species, then you have to modify this equation. For positively charged species you have to subtract -1, and for negatively charged species you have to add +1. So that is a different thing, we don't need that. Here we will stick to this formula: H is equal to V plus X by 2. Now using this formula you can get different values of H. The values range from 2 to 6, and if the value of H is 2, then hybridization will be sp, and the structure will be linear. If the value is 3, then hybridization will be sp2, the structure will be trigonal, and so on, so that you can look into the table. Now based on that we will see the structure of different molecules. For example, here first we have BeCl2, where the central atom is beryllium and it has 2 electron in its valence shell. So we put V2, and there are 2 chlorine atoms, so number of monovalent atoms are 2. So 2 plus 2 by 2 we get 2, so value of H is 2, and we know if the value of H is 2, the hybridization will be sp and the structure will be linear. So this is the structure of BeCl2. Similarly for Bf3, if you put all the values, the number of valence shell electrons in boron, you get sp2 hybridization and the structure will be trigonal. For methane it is sp3 and the structure is tetrahedral. For PCl5 it is sp3d hybridization and the structure is trigonal bipyramidal. Now let us go back into this slide. So here we have methane, we already have discussed the structure. For ammonia and water, in case of ammonia the central atom is nitrogen, and if you put all the values of V and X, you will get hybridization sp3, because value of H will be 4 here. But in this case, one of the sp3 hybrid is actually occupied by a lone pair. So when we look into the molecule we cannot see the lone pair, we can see only the atoms. So the structure of the molecule is tetrahedral, but actual shape of the molecule will be pyramidal, because one of the position is occupied by lone pair. Similarly for water molecule, the structure is tetrahedral, but two of the position or two of the sp3 hybrids are occupied by lone pair, so that's why the shape will be V shape. Okay, so this is a difference between shape and structure. Structure is whatever the hybridization will predict, and shape is when you put the lone pair, then how the molecule looks, that is the shape. And another thing is, um, in this case what you have to know is, so there is an important thing. um, when we are predicting the shape of the molecule, why we are telling that sp3 means tetrahedral? Because in case of sp3 hybrid we have 4 orbitals, and uh, tetrahedral arrangement is the only arrangement for 4 orbitals that will give lowest energy for the system. If you